Lists in Elixir can contain any type of data, such as integers, strings, maps, or tuples, just to name a few of the many possibilities. Now, generally speaking, we don't have different names for these lists you see here. We just call them lists. However, there is one type of list that has its own special name, which we'll talk about right now. If you've got a list that's made up of two-element tuples, like this, it's called a keyword list. So you might be wondering, what's so special about this kind of a list? I mean, why does it have its own special name? Well, keyword lists get used in a special way, which I'll give you an example of right now. To demonstrate how keyword lists get used, we'll play around with a handy function from the I/O module named inspect. The inspect function can be passed pretty much any type of data, and it'll print out whatever it's passed, and then it just returns the value it was passed. Now you might be wondering, what exactly is this inspect function for? In other words, when would you use it? Well, the inspect function comes in pretty handy when you're doing sophisticated data transformations, and maybe something isn't working like you thought it should be, or maybe you're just trying to track down a bug. You'll get a chance to use and appreciate the I/O module's inspect function later in this course when we start learning more about performing data transformations in Elixir. I'm going to create a variable named person, and I'll bind it to a map with a name field set to my name. An age field will be set to 45, and I'll set a gender field to the atom male. Now I'll go ahead and call the I/O module's inspect function, and I'll pass in the person variable. Okay, when I press enter, you'll see two nearly identical things get printed in the console. This line right here represents the inspected or printed value, and this line right here represents the returned value that IEX always displays. Now, if you're wondering, why is this function returning the value it gets? Well, hold that thought for now. It'll make a lot more sense later when we start using inspect in something called function piping or functional pipelining, which we'll get to in the near future. Now, imagine you're debugging, and you're using this inspect function all over the place, and you're seeing things like this line right here repeatedly printed in the terminal. For discussion's sake, let's just say you're seeing 10 lines similar to this one, and your terminal is getting a bit messy, and you're struggling to keep track of what each logged line represents. It'd be kind of nice if you could print a description by each value that's logged in the terminal to help you make sense of what you're seeing. Well, it just so happens that the inspect function allows you to print a description using a label optional parameter. But here's the thing. Label isn't the only optional parameter we can pass into inspect. There's about 10 total parameters we could pass in. So how do we pass a function somewhere between 0 and 10 optional parameters? One option would be to have 10 more function parameters, but that doesn't seem like a great idea to me. I mean, can you imagine calling a function with up to 10 parameters? I'm pretty sure I'd never remember the order to provide the parameters, and then what would you do if you needed to pass the 5th parameter, but not the 2nd, 3rd, and 4th parameters? So there's got to be a better way of passing in these optional parameters, right? Well, what if we wrapped up the optional parameters into a list? So instead of a function with 10 parameters, we had a function that just takes 2 parameters. The first parameter is the data to inspect, and the second parameter is a list with all the optional parameters we want to provide. So here's how this works. I'll hit the up arrow to pull up the last call to I/O inspect, then I'll add a list as the second argument, then inside the list, I'll add a 2-element tuple that represents a key value pair. In our case, we'd like to add a label, so I'll enter an atom named label, which represents the key of our key value pair. Then the second element of the tuple will be the value for the label, which I'll set to be the string step1. Okay, I'll go ahead and press enter, and as you can see, the label step1 was printed just before the value. Cool. It would be kind of nice to have each key value of this map printed on its own line for improved readability. We can achieve this by passing in another optional parameter named width. So I'll add a second item to this list, which will also be a two-element tuple, and the first part of the tuple will be the atom width, and I'll set the second part of the tuple to be the number 0. Setting the width to 0 forces each key value pair in the map to print on its own line. I'll go ahead and press enter, and as you can see, the map is a bit easier to read. But how readable is this list of options? It's kind of verbose and ugly, right? Luckily, there's a nicer option that I'm about to show you, but first I want to review something you learned a while back. Remember how maps can have a slightly different syntax when you use atoms as keys? I'll show you an example to jog your memory. Here's a map that has name and age fields that are strings. Now, if we change the keys from strings to atoms, we could go from this syntax to this syntax. I like this alternative syntax, and it's the syntax you'll often see used for maps in Elixir. Okay, so why do I bring this up? Well, there's a similar shorthand syntax you can use with two-element tuples, or what's called key-value tuples, in Elixir. So instead of this verbose syntax for a keyword list, which, by the way, is what this is called, we can use a nicer shorthand that eliminates the commas in the key-value tuples and moves the colon after the atom key, and we can get rid of the curly braces. In fact, watch what happens when I enter a keyword list into IEX in the longhand form. What's printed is the shorthand version, which is much nicer to read. Let's try this new syntax option with the inspect function. And as you can see, it worked. But there's actually one more thing we can do to make this function call a bit nicer yet. When you're calling a function and the last parameter is a keyword list, you can drop the square brackets, like this. Okay, that's a way nicer syntax, in my opinion, than we first used. Alright, going forward, when you see Elixir functions, I want you to take a closer look at how the parameters are sequenced. One thing you'll start to notice is that often the last parameter to a function is a keyword list, which allows you to use this nice syntax for passing optional parameters. Now, there's some other patterns you'll probably notice as well related to function parameters and how they're sequenced. So what's this other pattern I'm referring to? Well, I don't want to tell you just yet. I want you to try and find the pattern on your own first. But if you don't notice the pattern, don't worry, we'll review it in a later video. Okay, I've got an exercise for you to work on. You'll find instructions on how to complete the exercise after this video. Now, some of you are thinking, keyword lists seem pretty easy. I can just skip this exercise. Well, yeah, they are kind of easy, but you really shouldn't skip the exercises. Often you'll learn things in the exercises that I don't cover in the video, so don't sell yourself short and take a few minutes and complete the exercises. In the next video, we'll look at a data type called structs, which is very similar to maps, but it offers some nice benefits over maps.